This meeting is being recorded.
Right, thank you, Wei, for starting the recording. As you might know, this meeting is being recorded, and it will be uploaded to YouTube. Remember to adhere to the CNCF and Kubernetes Code of Conduct. So today we don't have any items in the agenda, but we are close to the enhancements freeze. So I figure we can quickly show you what's in the works for this next release. Can you give me permissions to share my screen? Oh, I do have them actually. So
yeah, Aldo, you're good to go.
Sorry?
Yeah, I mean, you're good to go.
Oh, yes. Is my screen being shared?
Yeah, I can see your screen.
Okay, perfect. So let's quickly recap sort of the 6 scheduling gaps. The first one is kind of obvious, or I guess we have been working on this for a lot of releases. We've gone through V1 Alpha 1, Alpha 2, been through a Beta 1, Beta 2, Beta 3. So after all these iterations, we think it's the time to finally graduate the scheduler component config to GA. And well, that practically means we're just copying the code, copying the latest Beta 3 API we have, and renaming it to V1. So this was fairly straightforward. I mean, in this release, but it was a lot of work throughout the releases. So unless there are any questions about this, I can move on to the next one. I'm not seeing, I'm not looking at the call, so please talk if you want to say something. Okay. The next one is a new feature. This we actually, oh yes, this is a new one. Basically, today, when you define a pod topology spread, you have to specify how to match the pods by specifying the label and the value of the label. This has been working okay, except when you have a rolling upgrade. So when you have a rolling upgrade, each version has a different label, and you might want to limit your spreading to specifically this version, right, or this version, or this replica set, so that once your replica set finishes upgrading, or I mean the old replica set is fully removed, your new replica set is fully spreaded. So for that, Alex introduced, or is proposing, a new API that simply expands the topology spread policy, so that you can just say derive the label from the current pod and use that to match with other pods. This, as far as I know, is already, yes, this is tracked, so this is good to go. It's just pending implementation and reviews. So that's the one. Any questions about it? Okay. The next one, I look at this. The next one, it is a graduation from alpha to beta. So I believe this one is also fully tracked. No, it just needs a few more tweaks. Okay, so what is this about? When you have a topology spread policy, currently the calculations are based on the nodes that exist. And this is somewhat limited if you have cluster autoscaler. If you have cluster autoscaler, maybe your zone today has, maybe your nodes are only in 2 zones, but you want to spread across 3 zones. So with this simple mean domains API field, you can now say, I want to spread among zones, but I also want them to be at least 3 zones. So if the scheduler doesn't find the 3rd zone, it would mark the pod. It would consider that zone. It would consider that there is a zone which has 0 nodes, and if the skew doesn't work out with that theoretical zone, then the pod doesn't get scheduled, and then the autoscaler would kick in, and you will have a perfect spreading after this autoscaler adds a new node. So that's this was already released as alpha in 124. We're targeting beta now in 125. Any questions about this feature? Okay.
So this has been implemented in the last release as an alpha feature, right? It has been merged.
Yes, it is alpha already.
Yeah, it's just we will evaluate whether we are going to promote to beta or something.
Yes. It's pretty much approved. It's just that the cap template changed.
Okay.
So and it needs to be updated. So that's what is left here.
Okay.
I think those are the non. Oh, I missed one. I missed this one. This one also topology spreading. We have 3 features just for topology spreading. This one, I think the cap was approved last release, but the implementation didn't make it. So yes, it had to be postponed 125. So what is this about? Pod topology spreading currently ignores taints and tolerations. So when calculating the skew, and we heard your feedback, and some people consider that this is not comprehensive enough. Like there are some use cases where you want to take into account what the tolerations and taints are. But then when doing this, we realize that we are already taking a decision about what to do with node affinity. So we also suggested that we add a policy for whether to consider the node affinity or not when calculating skew. So this cap is just introducing, well, it's introducing 2 fields, one for node affinity and one for tolerations, to determine whether or not they should be taken into account when calculating skew. And that's the feature. I think this is, yes, also has the same problem. It has an outdated template, but the code is already there. It's already, I think the code is even already merged. So the cap needs to be updated. Yes, so that is also going. That's going for alpha in 125. And I noticed, Wei, you added this one today, I suppose. This this is currently under discussion because there is a lot missing in the cap currently. So I'm not sure this is going to make it to the 125th release.
Yeah,
but
we will give a try to polish all the missing pieces, like the implementation details, as well as some like the explanation of how to integrate with the CA, cluster autoscaler, and something else. So basically, I think the idea has been brought up in previous meeting that we want a Kubernetes native API to represent a scheduling capability to schedule a group of paths altogether or schedule none of them. So that's basically a schedule directive we want to introduce natively. So that's the background. And in terms of the design and the implementations, there's still some details need to shape up. So yeah, me and Alex are working on it, and hope we can catch up for the freezing date next end of next week.
Right. Yes. As it currently stands, the CAP only proposes an API without implementation, and it's actually a goal not to give an implementation.
No. We are definitely adding the missing implementation part. I know that without an implementation, the API will have no chances to be landed.
Yes. So, and with that, I think the major concern from my point of view is that there are a few alternative implementations that are kind of looking at the same problem in different ways, and then we only have one chance, I think, to do this right, because if we later decide that we need a different API to tackle, as you know, like the reservations API that Abdullah is proposing, then we have 3 objects already in the database, which is problematic. I already know of some customers that don't even want to use job API just because that would duplicate the number of objects they have. So it's
yeah,
definitely
I agree. We do want to do it right from day one. But on the other hand, I'm seeking a way to do the things iteratively. Like, okay, we can't get this implemented, and additionally, adding the support for reservation for backfilling. So instead of so basically, I'm not that convinced that we need to get everything ready and then start to implement the idea. So like if the code scheduling is a standalone feature that can be implemented right now, so it's better to have the feature to open to the users. And when the reservation API and backfilling stuff are ready, they can add on top of the feature. That is how the principles we design each scheduling plugins, and each works independently with each other. But they can use as building blocks that stack together to satisfy a complex scheduling requirement scenario. Right.
So one good thing about having a new API is that it has to go through the alpha API phase, which guarantees that we can remove it. But this proposal is also adding as a field to the V1 pod spec, and that might be more problematic. So we need to figure out.
I'm not sure. I will let Jordan to comment. So right. Yeah. So basically, the functions. I'm aware of the reservation requirement that can not a guarantee, but best efforts to reserve some resources for the pod group, right? But the reservation can be only very call screen. I mean, so even if you reserve this kind of resource, there might be some like interpod constraints out there that you are pretty hard to reserve the resource on each node to quite satisfy. Otherwise, you have to make the knowledge of all the path distribution of the cluster view so they can make a very guaranteed reservation, right? So, I mean, my point is the reservation is the best efforts manner, right? So that is good to have to on top of the code scheduling, but code scheduling doesn't quite depends on the feature of reservation.
Right, but I guess the point is that they might be complementary features, but having two APIs might be problematic.
We have pretty a lot of scheduling directives just spread out of the pod, spread the API stuff. I don't see that a big problem. So if we start with day one, maybe we should have composed one single object called like scheduling constraints and put everything inside that. But I mean, this is current state, and we are not breaking that too much. So yeah, having two different APIs to represent its separate API semantics doesn't look like a big problem for me.
Well, I specifically mean multiple objects, but again, the problem is the size of the database. So, well, anyways, I think we can continue the discussion in the CAP.
Yeah, sure. Yeah.
Unless somebody else has specific question or thoughts in either this proposal or the other ones. Okay, let me stop sharing my screen. How do I cancel this? Oh, did I already stop sharing my screen? I'm confused. I guess I did. So with that, any questions you wanna bring up?
I guess if we have a second, I just want to call out that in the descheduler repo, we started doing some of the refactoring that we were talking about for trying to make it more of a framework, try to get the code a little bit more stable and more adaptable and customizable. So those changes are all going on in the repo. We talked a lot about it on these calls, in the past calls, and posted the design docs for it. So if anyone's interested or wants to help out or offer input, please feel free to join in on any of the pull requests that are opening. I know Jan has opened a couple already, and we're just going to start, migrating some of the internal code of the descheduler into more of a plugin design like the scheduling framework. So just a little shout out to that. That's all.
Thank you, Jan, Mike.
I see a question in the chat about Q. Q is a project sponsored by SIG scheduling as well, just like descheduler. And yes, it is. The question was whether it's a separate repo temporarily, or would it be merged back to kubescheduler eventually? Yes, it's a separate repo, and it's going to be a separate repo for the foreseeable future. I don't think it will ever be merged into kubescaler in particular, but parts of it could be merged into the controller manager, for example, or maybe just the APIs would be merged into Kubernetes. But that's something that needs to mature. It needs to mature more before we can even consider that. And it kind of relates to the pod group API as well, right? There is a similar API in Q. So it's also, it might also be valuable to somehow see if we can merge pod group with workload API, and they can share basically the same object in the future. But yes, it's still an open discussion, long-term discussion. And yes, we just released 1.0, sorry, 0.1.1 with a few bug fixes. Any other topics that folks want to bring to the meeting?
If you don't have any, I have a rough idea to improve the metric of measuring scheduling latency. But before I share, I can give time to any other folks who have other topics. If not, I can share my screen. I will take you another 5 or 8 minutes. Bear with me. So basically, in some production system, especially there's a lot of tenants, and in a like 3K or 5K nodes cluster, there might be some different priority paths, and your path scheduling may, your scheduling chances may be head of blocked by other paths. But right now, we don't have a very good metrics to measure that. So basically, if you look at this picture, a past successful scheduling may include several attempts. And each attempt include 3 kind of phases. The first one is that, okay, the path is literally ready to be scheduled. And so it be added to the active queue, the orange block. But that doesn't mean it will be immediately pop up to be scheduled, because there's maybe some other paths ahead of it, because maybe they have earlier timestamp to be added, or has a higher priority. So the path here has to be waited for its chance, and we are missing the time that the path is waiting in active queue. And also, then the next phase is that, okay, the path has its turn to be scheduled to be popped up. Then it enters the pure scheduling phase. That is usually the regular phase we are talking about, like prefilter, filter, pre-score, score, all the things happen in this phase. So we can call it either pure scheduling phase. And after that, if it's claimed to be unschedulable, it will have to honor the global backoff timer settings, so that it's like a penalty. So saying that, okay, you are unschedulable, you have to be sit there for a while, and until the backoff timer is up, you can be popped up back. So that is the backup queue. So for right now, there's in one attempt of the scheduling, the attempt, I mean, it might be a unsuccessful attempt because no node can fit the path. So we are missing the orange part and the green part, and we only have the blue part. So in the code is in the, it's called, the local variable is called scheduling latency, but the name in the metric is called scheduling attempt during seconds, and some legacy version is called the end-to-end, but the end-to-end is misleading, so we deprecated a little bit. Yeah, I think this matrix is deprecated, and this one should be replaced by this one. Okay, anyway, so what I want to propose is that we may want to record the duration in orange block or even the green block. So right now I did a POC internally is that I expose the orange block so that I add a face to the scheduling latency metric, and locally have some fake nodes, and I scheduled 200 paths which are unschedulable because I request 1024 CPUs. So I have run it for a while, for a few minutes. So let's take a look how the metrics looks like. So this is just like the current metric we have. So I want to check in each attempt the pure scheduling times period. So it's like, okay, I only spent 952 nanoseconds, which is pretty good because it's running in my local cluster and only 2 nodes. But I do not know how much time is spent in the waiting in the active queue, because if you look at the simulate the script, I randomly created the priority and set the priority to each pod. So there should be some queue sorting out there and some waiting time happens in here. Then I execute this query. So 90% percentile, and it spends, it's not a small number, it's almost 300 milliseconds, right? So if you want to break down some production issues, say, okay, a customer maybe ask you why my pod is staying there pending for so long time, and you want to narrow down, maybe it's a customer scheduling plugins, implementation issues, which cause the performance issue, or it's just waiting in active queue too long or waiting in back off queue too long. So that is the idea I want to bring. Just want to get you, although it's pretty preliminary, but to gather some feedback if you want to have some or have similar requirement.
If I may, this seems very valuable, but I think we probably want a new metric, just maybe dedicated to queuing time or something, queue duration, because the metric is already stable, right?
Yes. Yeah.
And
I can post a question to SIG instrumentation to see how it can be compatible to satisfy the
I think
stable.
it's not too bad to have it as a new metric, dedicated to queuing time, intermediate phase.
Yeah. And do you think the record the duration span in back off queue is valuable? For now, I didn't implement that. I just implement the duration in active queue.
I guess it could. So the active queue, you count from the time it enters the queue until it's popped.
Until it's popped up. Yeah, it's popped up. Yeah.
The other one would be from the time you requeue to the time it moves to active. It could be valuable.
Yeah, so that we have the full picture, how much time is spent on each sub phase of an attempt. But maybe we have to also introduce other label dimensions like priority to see each priority's path durations. Yeah, but yeah, just some early POC, and we'll try to draft the formal proposal. Okay, yeah, that's what I want to bring up.
If you have any links, would you mind?
No,
adding
no,
them?
it's just in my laptop. No
Okay.
formal design yet.
Okay. There are no other topics. Oh, there's one question. Always feel free to talk, but if not, I'm happy to repeat the question from the chat. Is there any benchmark to test the throughput of all or nothing scheduling?
Yeah, we have some general benchmark, and that fits the path, so we can just build up a scenario for the pod group schedulings. Then we will get the benchmark.
And there, I don't know if this was discussed ever, but there is some, at least I have some contention of using the term gang scheduling. I prefer
Yeah,
the term.
yeah. That is more in the inclusive perspective, so it's maybe more suitable to call it co-scheduling.
Co-scheduling or all or nothing, which is even more more expressive.
Yeah.
All right. With that, I think we can close this session. Yeah, just remember the enhancements freeze is next week, and yeah, if you still have any proposals, you have some time, but it's very limited. So, okay.